Welcome to the lecture series of functions of several variables. Today we are going to discuss about Taylor's theorem for functions of two variables. Taylor's theorem for one variable we have studied in 12th standard. So here we are going to discuss about Taylor's theorem for functions of two variables. Consider f of x comma y as a function of two variables. Then the Taylor's theorem for functions of two variables is f of x comma y is equal to f of a comma b plus 1 factorial into x minus a into fx of a comma b plus y minus b into fy of a comma b plus 1 by 2 factorial into x minus a the whole square f xx of a comma b plus 2 into x minus a into y minus b into fxy of a comma b plus y minus b the whole square into fyy of a comma b plus etc. This is our equation 1. In this equation, if a equal to 0 and b equal to 0, then the equation 1 becomes fxy equal to f of 0 comma 0 plus x into fx of 0 comma 0 plus y into fy of 0 comma 0 plus 1 by 2 factorial into x square fxx of 0 comma 0 plus 2xy fxy of 0 comma 0 plus y square into fyy of 0 comma 0 plus etc. This is our equation 2. Equation 2 is known as Maclaurin's series for two variables. To expand f of x comma y in the neighborhood of a comma b, that is, expand f of x comma y in powers of x minus a and y minus b, use equation 1. Use equation 2 to expand f of x comma y in powers of x comma y or in the neighborhood of origin 0 comma 0. So equation 1 is Taylor's series for two variables, that is f of xy equal to f of a comma b. Here we have written f suffix x. It's understood that derivative of f with respect to x and here with respect to y and double derivative with respect to x, and here also x as well as y, derivative with respect to s, x as well as y, and here it is derivative of y 2 times at the point a comma b. That is called Taylor's theorem for f of x comma y under two variables. In the two variables, if a equals 0 then b equals 0, this equation 1 will become as like this, that is equation 2, and this is called it as Maclaurin series for two variables. So for doing problems under Taylor's theorem, how we are going to do the problem means, for the given function, first we are going to find the first derivative with respect to x and y, then the second derivative with respect to x as well as y and xy. After find out all the derivatives, that is fx, fy, f(x), fxy and fwy. After find out all these derivatives, we are going to substitute the point a and b, we will get the value. After find out the values, back to this equation, substituting all the values in this result, we will get the required Taylor's series for the given function. If suppose the point is not given in the question, that is a0, b0, then we are going to use the result 2. That is what written in this place. Okay. So we will see the problems. Look at the first question. Expand e power x sin y in powers of x comma y up to second degree. So in this question, it's given that expand e power x sin y in powers of xy up to second degree. Nothing is given apart from this. That is, it's not mentioned directly whether we are supposed to use Taylor's series or Maclaurin series. So instead of that, it's given that in powers of xy. It's understood that in Taylor's theorem means we are supposed to write x minus a and y minus b. Okay, here it's given that x comma y. So obviously it's understood that the neighborhood point is 0 comma 0. That means we are supposed to use the Maclaurin's result, that is the equation 2. So first we will take the given one as f of x comma y. So look at the solution. Let f of x comma y is equal to, okay, so the given function we will take it as e power x sin y as f of x comma y. Okay, so it's very understood that up to second degree the powers of x comma y. That means the x minus a and y minus b, instead of that it's given that x comma y. So obviously a is 0, b is also 0. In that case we are supposed to use Maclaurin series. So we have taken f of x comma y as e power x sin y. So instead of x and y we are going to substitute the point as 0 comma 0. Okay. So f of 0 comma 0, simultaneously we are supposed to find the value, so that when we are applying the result it will be very easy. Okay. So x is 0 and y is 0. What will happen? E power 0 is 1 and sin 0 is 0. So we can get f of 0 comma 0 is 0. Then all the derivatives first we are going to find, that is fx suffix x means derivative of f with respect to x. Okay, partial derivative of f with respect to x. So when we are differentiating partially with respect to x, we have to treat the y term as a constant. So here sin y is constant, and then differentiation of e power x is e power x. So what is our fx of x comma y? That is e power x sin y. Okay. So fx of 0 comma 0, side by side we are supposed to find the values. Okay. So instead of x 0 and instead of y we are supposed to put 0. So what will happen? E power 0 is 0 and this one is 0. Okay. Then fy of x comma y. So treat the e power x as constant. Differentiation of sin y is cos y. Okay. Then fy of 0 comma 0. E power 0 is 1 and cos 0 is also 1. So fy of 0 comma 0 is 1. Then the next one is first derivative is over. Then second derivatives, that is fxx of x comma y. So already we got fx. Again we are going to derivative this function with respect to x partially. So e power x is e power x. Treat the sin y as a constant. Okay. So f double x of 0 comma 0. Okay. So this will become as 0. Then f y of x comma y. Already we got fy. This function we are supposed to derivative with respect to y. Okay, differentiate with respect to y. So what will happen? Treat the e power x as constant and differentiation of cos y is minus sin y. So here it is minus e power x sin y. Again substituting x as 0, y is also 0. So what will happen? Sin 0 is 0, 0 into anything 0. Okay. Then the last one is fxy of x comma y. So what is this? This is actually second derivative with respect to x and y. So fy, that is already we got fy. For this function derivative with respect to x, so that we will get fxy. Okay. So here our fy is there. So for this only we are going to derivative with respect to x. So what will happen? E power x differentiation is e power x. Treat the cos y as a constant. Okay. So making the place x and y as 0, what will happen? E power 0 is 1 and cos 0 is also 1. So this will become as 1. So like this, side by side we are supposed to find the first derivative, second derivative, all the the values, so that when you are doing the final result it will be easy. So the Maclaurin series fxy of f of 0 comma 0 plus x into fx plus y into fy plus second term, like that it will go. So without fail we have to write this plus dot dot dot. Okay. Now we are going to put the values f of 0 comma 0, that is 0, and then fx of 0 comma 0 is 0. So we will substitute all the values here. Okay. So f 0 0 is 0 plus x into fx of 0 comma 0, that is also 0, plus y into fy 0 0, that is 1, plus x square. Okay. This is the first term is over. Then 1 by 2 factorial into x square fxx 0 comma 0, that is 0, plus 2xy into fxy of 0 comma 0, fxy of 0 is 1, okay, plus y square into fyy of 0, that is 0, plus etc. Okay, without fail we are supposed to write plus etc. Okay, so which is equal to, first term is 0 and 0 into anything 0, then here we are having only y. So y plus and x square into 0, 1 by 2 factorial is 1 by 2 into the first term x square into 0. So, this will become as 0 plus 2xy plus y term is also 0 into anything 0 plus etc. So, what is the answer? Y plus 1 by 2 into 2xy plus etc. So, we can cancel the 2 also. So, which is equal to y plus xy. So, the required series, okay, we have to put without fail this plus dot dot dot, then only it is understood it is a series. Okay. Therefore, what is our left hand side? F of x comma y is equal to y plus xy plus etc., which is the required series for the given f of x comma y. Look at the second question. Expand f of x comma y in the neighborhood of 1 comma 1 and f of xy is equal to tan inverse of y by x. So, in this question it is very clear that it is understood we are going to find the Taylor series because the point is 1 comma 1. That means we are supposed to expand the given f of xy in powers of x minus 1 and y minus 1. That means a is equal to 1 and b is equal to 1. So, we are going to use equation 1, that is Taylor series. Okay. So, first we will take the given one. Given f of x comma y equal to tan inverse of y by x. Okay. Point is 1 comma 1. So, we will find f of 1 comma 1. That means for y is also 1 and x is also 1. Tan inverse 1. Tan inverse 1 is equal to f of 1 comma 1 equal to tan inverse 1 is pi by 4. Then the first derivative f x of x comma y. Tan inverse x differentiation is 1 by 1 plus x square. That means y square by x square into differentiation of 1 by x is minus 1 by x square. Treat the y as a constant. So, minus y by x square. Taking LCM. So, this will become as x square by x square plus y square into minus y by x square. Okay, when you are taking the LCM, x square plus y square divided by x square, this x square will become into the numerator, so that it comes x square by. So, now we can cancel the x square. So, what is our fx of x comma y? Minus y by x square plus y square. We will substitute the point fx of 1 comma 1. So, minus 1 by 1 square plus 1 square. So, minus 1 by 2. Okay. This is our fx at 1 comma 1. Then same manner fy. Okay. Derivative with respect to y. In this case you have to treat the x as a constant. So, tan inverse y by x, differentiation of tan inverse x is 1 by 1 plus x square. So, y square by x square. Then differentiation of y is 1. So, treat the x as a constant. Okay. Cross multiplying this, we can get x square by x square plus y square into 1 by x. Can cancel the power. So, fy of x comma y is nothing but x by x square plus y square. We will substitute the point at 1 comma 1. Okay. So, 1 by 1 square plus 1 square, that is plus 1 by 2. This is our fy. Okay. Next, second derivative, that is fxx of x comma y. Already we got fx. So, for this only we are going to find the second derivative with respect to x. So, what will happen? Treat the y as a constant because derivative with respect to second derivative with respect to x. So, in this case we are going to treat the y as a constant. So, we can take the minus y outside because it is a constant. So, what is the remaining? 1 by x square plus y square. Differentiation of 1 by x is minus 1 by x square. So, minus 1 by x square. So, x square plus y square the whole square into differentiation of x square, that is 2x. Is it clear how we are doing this? Treat the minus y as a constant. Differentiation of 1 by x is minus 1 by x square and then differentiation of x square is 2x. Now, minus into minus plus and y into 2x. So, this can be written as 2xy. Okay, 2xy divided by x square plus y square the whole square. What is this? This is our fxx of x comma y. Now, we will substitute the point. So fxx of 1 comma 1 equal to 2 into 1 into 1 divided by 1 square plus 1 square the whole square. So what will happen? 2 by 4, okay, 2 by 4 which is equal to 1 by 2. This is our fxx. Same manner we are going to find fyy and fxy. So for the fyy we are going to find the second derivative of fy. So this is our fy. Fy of x comma y is x by x square plus y square. For this only we are going to find the derivative with respect to y. In this case we are treating the x as a constant. So what will happen? Treat the x as a constant. So keep x as it is. Then differentiation of 1 by x square plus y square. So this is of the form 1 by x. So minus 1 by x square plus y square the whole square into differentiation with respect to y. That means y square differentiation is 2y. So what will happen? Which is equal to minus 2xy divided by x square plus y square the whole square. What is this? This is our fyy of x comma y. Okay, it's understood, x comma y. So now we will substitute the point fyy of 1 comma 1. Okay, so minus 2 by 1 square plus 1 square, that is 2 square is 4. So which is equal to minus 1 by 2. This is our fyy at the point 1 comma 1. So now the last one is fxy. Now the last derivative is fxy at the point of x comma y. That means already we got fy. Okay, already we got the fy. So for this only we are going to find the second derivative with respect to x. So in the numerator as well as the denominator we are having the x term. That means we are going to use the u by v result for finding the fxy. Okay, so denominator is x square plus y square. That means x square v square. So x square plus y square the whole square v x square plus y square. Differentiation of x is 1 minus, keep the x as it is. Then differentiation of x square is 2x, because derivative with respect to x, in that case differentiation of y square is 0. Okay, can close the bracket. Now x square plus y square minus 2x square divided by x square plus y square the whole square. Okay, so this is our fxy at the point x comma y. So now we will substitute the point. Okay, so here what is the point? Point is 1 comma 1. So fxy at the point 1 comma 1. Okay, so what will happen? Fxy, here it is 1 plus 1 minus 2 divided by 4. So 2 minus 2, 0. Okay, 0 by anything, 0. So the second derivative of that is xy is 0. Now we will write the required equation, that is the required Taylor series. So by Taylor's theorem, f of xy equal to, this is the result, f of a comma b plus x minus a. So in this problem, a is 1, b is also 1. Therefore, f of x comma y is equal to f of 1 comma 1 plus x minus 1 first derivative at 1 comma 1, y minus 1 into first derivative of y with respect to y at 1 comma 1. Then 1 by 2 factorial into all the second derivative plus etc. Without fail, we are writing the plus dot dot dot, because it is a series. Okay, now we got all the values for the derivatives, that is f of x comma y at the point 1 comma 1 and the first derivative at 1 comma 1 and fy at the point 1 comma, all the values we are going to substitute in the formula. So when you are substituting that, f of 1 comma 1 is pi by 4 plus x minus 1 into fx of 1 comma 1 is minus 1 by 2, y minus 1 into fy of 1 comma 1 is 1 by 2 plus the 1 by 2 factorial, second derivative at fx 1 comma 1 is 1 by 2 and here it is y minus 1 into fxy at the point 1 comma 1 is 0 and the last value is minus 1 by 2. So the second term fully becomes 0. So pi by 4 minus x minus 1 by 2, here also y minus 1 by 2 and then this one is 2 factorial value is 2 and then this 1 by 2, so that we can get x minus 1 the whole square by 4 and then here it is minus y minus 1 the whole square by 4. Here it is 1 by 2 factorial and here it is 1 by 2. 2 factorial is 2. So 1 by 2 into 1 by 2 we can get 1 by 4. Okay, so x minus 1 the whole square by 4 and the whole term will become 0. Okay, 0 and anything 0, and the last term is minus, here one minus is there, so minus y minus 1 the whole square by 4 plus etc. So this is our required Taylor series for the tan inverse of y by x. So like this only we are supposed to do the problem. Only thing is the way of identifying the point, that is a question whether we are supposed to use the Maclaurin series or Taylor series, that is a thing. So in the look at the first question, it is given that expand in powers of x comma y. So it's very obvious that the point, that is the neighborhood point, is 0 comma 0. The second question, it's clearly given in the question itself, the point is 1 comma 1. So in this case we are supposed to use the Taylor's theorem. So this is the way we have to identify the question in the examination. Okay, thank you for watching.